Well, we're looking here at a gCADPlus design for an irrigation layout. It's a very large site in rural Western Australia, and the area of interest here, the area to be irrigated, is nearly 10,000 metres square. Well, we use the area command, that's this one up here, and just measured and lay an area out over the zone that is, and when we click here, that gives us an area measurement down in the command area, but that yellow overlay is not part of the actual drawing. Just right click and it disappears. If we zoom in on an area of interest, I hope you can see that we've taken symbols from a palette on the right hand side, symbols for water supplies, solenoid, controllers and flush valve assemblies and backflow devices and so on. These are all plugged into the irrigation lines. Notice though, when I click on this polyline through here, it's on a layer L-irrig, as all the irrigation layout goes on that layer, but with another rider -PVC 25. So that's pipework 25mm wide diameter in PVC, and if we get the magenta line, that's PVC 20mm piping. Well, where two lines join or meet, they're both PVC 20. We put a little T block symbol there, a T joiner if you like, and it's called PVC 20mm T. It's a T junction that will need to go in there and will need to be purchased. Similarly, here's an end plug which will go on the end of that line. And we've done the same sort of thing for the other lines. Here's PVC 25, and we use colour to distinguish it, and here's a similarly coloured PVC 25mm elbow, and somewhere in the drawing you find some symbols that go at a 45 degree. So we've got all of the irrigation lines in, all on their own layer, along with symbols representing T-junctions and elbows and angle joins and end points that we're going to need. These constitute quite a large number of individual items that will need to be purchased to implement this design. One of the things your installation team will need will be a total length of pipes. Because both the 20 and 25mm lines are on their own layer, there's the 25 line and there's the 20, well, we could use one of the tools in gCADPlus, and that is to isolate a particular layer. Let's start with PVC 20, and we can just say OK. That isolates the 20mm internal diameter pipework. So we want the total length. So it's just a matter of going tools and add up the length, and we're asked to select it. So we just use a window and we get a value of 379674, and if I hit enter, that pops it up into a length string, and I can copy that, and that's ready to paste back into the design because your team will need that figure. I'll cancel from there and we'll just repeat that, but this time we'll go tools and isolate a layer, and this time it's the PVC 25, and we isolate that layer, and there it is. So we can isolate that and get the total length of the pipe. So it's add up the length and do that. So again, we've got 171 meters of that length of piping, and that can be copied again to the clipboard. We'll then go back to our layers and then right click on all use layers and put the visibility back on, and there we are, back where we started. So we now have two key pieces of information: the total length of pipework. The next thing is we want to get a list of all of the hard elements that are in the drawing, all these sprinklers and the connectors and control valves and so on. Everything that's in the designer has put in there, we want to total it up. Well, gCADPlus has a tool to make that task quite straightforward. We go to the gCADPlus drop-down menu, extract block data. We want to extract blocks from an area, so we just wrap a box around the area, and you can see I have just missed this one on this side, so I'll cancel from there, right click and run that extract block from an area command again and do it. Notice that the SUV, the car, is selected, and I can just hold the shift key down and click it again. So that's all we need to do. That's grabbed all of those blocks, and we'll save it on the desktop as irrigation 01, and that's now been done. Let's turn now to Excel, and we'll say a blank workbook, and we'll go to data from text, because we've just written out a CSV file, and we'll go to desktop, and there's irrigation 01, and we can import the information we just exported and bring it into an Excel spreadsheet. You could use other spreadsheets besides Excel, but here's all of our data. Now, we're only interested in the information that's in column B, so we can pick column C, use shift and then right click and hide these. We'll also hide column A. Whoops, I need to select the column first and then right click and hide. Now we have all of the blocks representing the various components. You could leave it like that and just put little insert rows between each of the groups, which I think is probably the easiest way. So you can see what I'm doing. I'm just breaking this up into the various groups. You could very easily write an Excel macro to do this, and then in that particular cell or in the cell adjacent to it, you just use the count function to count all of the symbols, all the elbow symbols, and then all the T symbols and so on. So we have the data that we want already. We just need to formulate it and present it a little easier. And I think to have a little mini program in Excel that would do it for you would be a good little exercise. So I hope that shows that with Excel it can function as a tool to do quite detailed irrigation design work and extract quantities from your design. To take things a little further in the Excel environment, I've put a count function in this particular cell, count if there's the range, and we could just shift and highlight those rows and hide those. So we have 3 Hunter 10-foot Pro. If we come down here, we need 19 Hunter MP 2000. We might need to widen the column just a little and do exactly the same again. It's just a matter of, in this case, hiding 19 rows and hide those. So there's our 10-foot Pro Hunter sprinklers and the rotator full circle, the pump and the controller. We can take this line out, so you can see it's a pretty easy job to produce a little Excel spreadsheet, and we can turn that into an image and pop that back into the drawing. And that, I think, completes the demonstration.